Welcome to Global Future School. Students, I am Dr. Jalwana, your chemistry tutor. Today's chapter number 2, chemistry first year, and the topic for today's discussion is discovery of proton. Students, you will come to know how the proton was discovered and what are its properties after completing this topic. Students, before going into the detail of the discovery of the proton or positive rays, first positive rays, then proton was discovered. I must recall you about the discharge tube, because positive rays and then proton, they were basically discovered in the same discharge tube that in which the cathode rays and electrons were discovered. They have the same basic construction, a glass tube, gas inside. Gas can be any type of, it can be vapors and it can be mixture of gases, it can be any type of the gas inside. Two electrodes, anode and cathode, when they are attached to the high voltage battery, and a vacuum pump to adjust the pressure inside the tube. So students, this was discovered by a German physicist in 1886 by Goldstein. And just consider this is a glass tube, and it has the same components of discharge tube. This one is anode. When this is attached to the battery, positive terminal, this is cathode, this is negative. So when these are attached to when the battery is on, then they are anode and cathode. Otherwise these are just plates, metal plates. Vacuum pump to adjust the vacuum inside, and inside is the gas. This one is the gas molecules, and inside the gas it can be neon, it can be helium, it can be hydrogen, and generally I can write M. M stands for any type of the gas inside, any type. So students, previously when this high voltage battery is high voltage is applied with the help of battery at low pressure, cathode rays from the cathode, like these, they appear and they travel towards the positive terminal, or you can say the anode, because they carry the negative. They produce from the cathode and they travel towards the positive pole, and that is the anode. But at the same time, Goldstein observed that there are some other rays that travel opposite to the cathode rays, and for this purpose they did the canals. They produced the holes inside the cathode. That's why these are also called the canal rays, on the base of these holes. What happened basically, how this positive charge, now you can say this is neutral particle, but when they come across these cathode rays knock out their electrons, and as a result they got positive charge, and these negative travel towards the positive. But when they got positive like this, they travel towards the cathode and they pass through these canals. On the base of these are called positive rays, or other name is canal rays. Canal rays, just on the base of these, are passing through the canal. If this is neon gas, like this neon, when electron cathode strike on these cathode rays knock out the electron of the neon. As a result, it got a positive charge. Similarly, it can be helium. If the one electron of helium is removed, then it got a positive charge. If this gas is like hydrogen, then one electron, when it is removed, this is a positive charge. Because they got positive charge, then they start traveling towards the negative pole, and they pass through these canal, and these, on the base of these, are called the positive rays, or these are called the canal rays. So in the same discharge tube where cathode rays were produced, they also produced the positive rays, and they also named the canal rays because of just they are passing through the canal. And these were discovered by Goldstein. He was a German physicist. As students, that was the discovery of positive rays, production of the positive rays, and what are its properties, and how these positive rays, with the help of these positive rays experiment, proton was discovered. Application of the discharge tube, like for cathode rays and electrons, they also scientists determine the different properties of the positive rays, that are like they travel in straight line perpendicular to the anode surface when there is no electric field or magnetic field. So in the absence of any electric field or magnetic field, positive rays also travel in a straight line. But when electric field or magnetic field is applied to they can be deflected, and on the base of their deflection, because they deflected towards the negative pole, or you can say to the cathode of the electric field, towards the negative pole, that shows these rays contain the positive charge, they have the positive charge. And they also produce the flash on zinc sulfide. If we place a photographic plate is usually coated by zinc sulfide, then they produce the spots on that photographic plate, and they produce some flashes. Charge to mass, because these are charged particles and they have the mass, so charge to mass ratio depends upon the nature of the gas inside tube. So if you remember, in cathode rays, you can say charge to mass ratio of cathode rays was always same, that was exactly like that of electron. But in this case, charge to mass ratio was depending upon the gas inside the tube. Every time charge to mass ratio was different. Why? This I already told you in previous lecture, that charge to mass, of course, that will be different. This is the charge to mass. Now if you can see, neon has its own mass, helium has own mass, hydrogen has its own mass, and the lowest mass of in this is hydrogen, then helium, then neon. So if you are using different mass, of course, if you are using the mass of neon, its value will be different than if you are using the mass of helium, and if you are using the mass of hydrogen, because its mass is varying, its mass is changing, so charge to mass of every gas that is used in the discharge tube will be different. So charge to mass value of these rays, that depends upon the nature of the gas inside the tube. And the highest charge to mass ratio that obtained in this case was when they used the hydrogen gas as inside the discharge tube. So charge to mass ratio was highest. Why? This is question for you. I already told you. Because hydrogen is the lightest element. That's why, because it's the lightest element and there is charge to mass. Mass is dividing. So its charge to mass ratio will be higher. And the mass of positive rays is never less than that of a proton. It's the same thing. All the gas that is used in the discharge tube, they have the mass never less than that of the proton. It means proton or hydrogen atom is the lightest. Its mass is the lightest, it's the smallest mass than any other element that is used inside the discharge tube. So the positive rays that obtained from hydrogen gas is lightest among all the positive, because hydrogen gas is the lightest. So positive rays that were obtained by using different gases inside the tube, among them the hydrogen gas, positive rays obtained using hydrogen gas, that is the lightest. So this particle that obtained from hydrogen positive rays, that is called proton. This name was given by Rutherford. Rutherford gave the name proton to this hydrogen atom, because we already know hydrogen atom is the single atom that is made by one proton and one electron. There is no neutron, and this is the lightest element among all the elements in the periodic table. And this also already we know, mass of proton is 1837 times more than that of electron. So students, there is question for you. Charge to mass ratio of positive rays is smaller than that of electron. I already told you in the previous lecture, just recall. While charge to mass ratio of proton is less than the electron, because this depends upon the mass. Students, with the this experiment and all the properties we have discussed, what we conclude basically? We conclude that as proton is present in all atoms, whichever the gas you have used in the discharge tube, they produce the positive rays. So it means proton, this hydrogen atom, basically that is a single proton. Electron is almost massless. So proton is a common and stable constituent of all elements, all matters, and proton is the fundamental particle of all the elements. Only hydrogen contain proton and electron, while all other contains electron, proton and neutron. So first we have observed that electron is fundamental particle of all the matters, and now we have observed that proton is also a fundamental, you can, this is the common and stable constituent of all the matter that we have in this universe. So students, today we have observed the discovery of proton with the help of discharge tube experiment and properties of proton, and our next topic will be about the discovery of the neutron, that is also a third fundamental particle of all matter.